Hello and welcome to the last recorded video for you guys prior to us beginning our live classes again on Wednesday. So I'm out doing Makeup Ohio graduation testing Monday and Tuesday this week. So I've recorded a series of short videos for you guys to watch for Monday and Tuesday. And this will be the last video for Tuesday before we meet again on Wednesday. We are going to be working in Unit 3, Lesson 2, where we work with arc and angle measures and circles. So in the first couple videos that we've done so far, we have identified and found the measures of arcs. And then in the past few videos, we've been working with inscribed angle measures and angles on and inside circles. Today we're going to work with angles formed inside of circles to solve problems. And then you can see the rest of the week is outlined. Wednesday we're going to use angles outside circles to solve problems. Thursday we're going to do proving circles are similar and using inscribed polygons to solve problems. So let's pick up where we left off. We talked about angles on circles. Now we're going to move on and talk about working with angles inside circles. So remember, angles on circles were where the vertex was on the circle itself. This time we're going to talk about segments intersecting inside of a circle and the angles formed by those segments. So our first theorem is the intersecting chords theorem. And we can see in this diagram that we have two chords intersecting inside the circle. We have this green chord and we have this yellow chord. And they intersect to form two angles, and these angles have to be congruent, right? Because in other words, without the circle, they're just our normal vertical angle pairs. So we can see that the two angles we're looking at, angle SVR, is actually equal to the measure of TVQ. So that's this red angle here and this red angle. Now the intercepted arcs are not necessarily congruent because V is not the center of our circle. So we want to be careful for that. But what this theorem says is the measure of the angle formed by two chords that intersect inside a circle, the green and the yellow chords, is the average of the measures of the intercepted arcs. So what I do is I find the measure of, and I'll use a different color, I'll find the measure of this blue arc and the measure of this blue arc. Even though they might be different, I'm going to add them together, divide by 2, and that gives us the one of each of those red angles. So, in other words, the measure of SVR is half of the measure of those two arcs added together, arc SR and arc TQ. And that's also going to equal this same angle in red that we see. I could also do the same thing with the other pair of angles. Let me use a different color here. Let's say that I was looking at this angle here. Well, that is a vertical angle to this one over here, so the same rule applies. Only this time I'm averaging the other two, pick a different color, the other two arcs. So arc ST and arc RQ. And that would be these angles here. So let's just practice. Let's practice working with this intersecting chord theorem in the next few problems. So here we are given a similar diagram as what we saw in the last theorem. We want to find the measure of angle AEB. Well, that is the angle formed by these two chords that intersect inside the circle. Now, I can't assume that E is the center point, right? Because it would be visually in the center of the circle, or some information would be given to tell me E is the center. So without knowing that, it's not necessarily the center. But what I can do is I can use my intersecting chords theorem to say that this angle right here is equal to the sum of the two intercepted arcs AD and BC multiplied by 1/2. So let me write that out. I can say the measure of angle AEB is equal to 1/2 times those two arc measures added together. The measure of arc AD plus the measure of arc BC. And so let's plug this in. Now, we want to be careful here. I know that, oops, I want to find, I guess I used the wrong one. Let me erase this. So I picked the other pair that we don't know about. Let me use my eraser real quick. I want to find AEB, and I picked the wrong one. I picked AED. So we're actually using the other pair of angles. Let me start over. We want to find AEB. That's A to E to B, right? And that's formed by the same two chords, but we're looking at the other pair of angles. We're looking at AEB is what we want to find. So that means we're going to average the two intercepted arcs AB and DC. Alright, now that I have the right angle pair, the measure of angle AEB is going to equal 1/2 times the sum of those two arcs added together. So the measure of arc AB plus the measure of arc DC. So if I want to find this measure here, then I just add those two arcs together and then multiply by 1/2. So 139 plus 113. So do what's inside parentheses first. 139 plus 113 gives me 252. Then I can multiply that by 1/2 or divide by 2, whichever is easier for you. And that will tell me that the measure of angle AEB measures 126 degrees. So that's this angle as well as this angle down here, because these are just vertical angles. They have to have the same measure. All right, let's try one more practice problem of this. Maybe I can pick the right angles for you guys. Okay, so here I want to find the measure of ABD. There we go. ABD is this angle here. So using this intersecting chords theorem, I'm going to find the average of these two intercepted arcs. So I can say the measure of angle ABD is equal to 1/2 the sum of the measure of arc AD plus the measure of arc EC. Now I know AD is 65, EC is 37. So I'm going to take 1/2 of 65 plus 37. And so if I do the parentheses first, that's 102. Then I multiply by 1/2 or divide by 2, and I get that that angle measures 51 degrees. And if I wanted to find this angle over here, it would have to be the same measure. Okay, so that's using the intersecting chords theorem. Pretty quick, I think. Just averaging those intercepted arcs together. Thank you guys for watching, and I will see you Wednesday morning at 9:15.